So collections are, basically, it's a group of elements, a group of objects. So it's a ready-made framework to store the dynamic elements or dynamic objects. That is what the collection means. Collections, you use it to do a lot of operations. You can perform on data for searching the data or for sorting the data, inserting the data into the collection. You can do delete this particular elements. So there's a lot of operations if you want to do. With the methods, you can do that. So that's what the collections. A collection is nothing but a single unit of many objects. That is called Java collection means. So collection are available in the java.util package. You can see here. So in this package, you can find all the collection framework classes and interfaces. So the top row interface is iterable. Then the child of this one is a collection. A collection has a many child interfaces: list, set, queue, dequeue. So these are the different sub interfaces are there under collection. So set has a sorted set sub interface. So these are all the different collections are available. And so what are the, again, this class, this interface is implemented in these classes. So list is implemented in the arrayList, linked list, vector classes. Set is implemented in the hash set, linked hash set, and tree set. So queue is implemented in the priority queue class, but the dequeue is implemented in the arrayDequeue and a linked list class. So the linked list is implementing the two interfaces. One is a list interface, another one is a dequeue interface. So linked list you can use as a queue or you can use as a list also. So that's the class which is implementing two interfaces. Okay, so what are the, so again, interface means it has all abstract methods and you have to implement them in the some classes, right? That's what I see. All these yellow color one are interfaces. So we are implementing in these classes. So we are implementing in these classes. And these classes, so have a lot of methods. We'll discuss one by one. But first, let's understand this collection interface has what are all the methods. This collection interface has so many methods. So let's understand these methods and we can go for the list to set and other things. The first method is add method. So you can add a particular element to the collection with the add method. So this add method is used to insert an element into the collection. So how to call this method? The collection name dot the add method. So object element. And this mainly used for storing the objects. So storing objects, you will use these collections. So dynamic data, if you want to store, you can use these collections. So array you will use to store a fixed data type, fixed size, and a static. That is a static data you can store in the array. But here collections are mainly used for storing a dynamic data. Dynamic data means as objects you can store. So there is a add all method. Collection of elements you can add to the existing main collection. So collection name dot add all and another collection. So you can join two collections with the add all method. So this collection will go and join here in this collection. So all these collection elements will store here in this collection. If already elements are there, last element after these elements will go and add here. So that's the add all method. Then we have a remove method. So remove object element. So it is used to delete an element from the collection. So collection name dot remove object element. And remove all. So collection C. So this is used to remove a collection of elements from the main collection. So these elements will be removed from the main collection. So collection name dot remove all collection C. So that's a remove all method. Then there is a size method. So size method, what it will do is, so it returns the total number of elements in the collection. So it returns the total number of elements in the collection. So collection name dot size. Collection name dot size method. So this is the count collection name dot size. And there is a clear method. So clear method basically removes the total number of elements from the collection. So you will use mostly this size method, add method, the clear method also will call. And then next one is contains method. So it searches the given element is present in the collection or not. If it is present, returns a Boolean value true. If it is not present, returns a false. Another most important method, iterator method. So you want to iterate your collection of elements one after the other. How can you iterate? So you can do with the iterator method. So iterator method is used to iterate one by one element. And this method returns an iterator interface. This is the iterator is an interface. Iterator interface and it variable, one by one element will come and store there. So then if you want to get this element, you have to use this iterator methods. So we'll discuss them in the coming, so soon after these methods. So there is a toArray method. Basically it converts the collection into array format. So that returns an object array, object return type. So object return type array name equal to collection name dot toArray. So you can convert the collection into array format. So there is a isEmpty method, equals method. So isEmpty, so it checks if a collection is empty or not. Collection is empty or not. So public Boolean equals object element. So matches two collections. So Boolean B5 called collection element dot equals the element. So public Boolean retain all. So you can retain all these elements. You can retain all these elements. It is used to retain these elements and removes other elements. That's a retain all. So this is how retain all will work. Okay, so and then, so don't confuse with the remove all and return all. The remove all is whatever you specified here, those will be removed. But here retain all, whatever you specified here, those will be retained. So only these elements will be retained. Remaining elements will be removed. So that's a retain all and remove all difference. So equals method, another very important method to compare two objects. You will use a equals method and also hash code method. So hash code method is another one which fetches the hash code value of your object. So basically the collection contains objects. That object hash code value, if you want, you need to use hash code method. So hash code and equals method, you should override wherever you are using. So that why you need to override, so why you need to use them. So I will discuss maybe in the coming classes. So this is the iterator interface I was talking, iterator method, right? So this iterator method. So when you use this is the syntax as it is you are going to write. Whenever you have a group of elements in your collection, you want to iterate, you can use this syntax. And you have to call. So iterator interface provides the facility to iterate the elements in forward direction only. So only one direction you can iterate the elements, not in reverse direction. So there are only three methods. One is has next method, and mostly we'll use these two only. And remove method is there one more, but we won't use that much. So what this has next method will do, it returns true if iterator has more elements. And next method, it returns the element value and moves the cursor to the next element in the collection. So that's the next method. So it just checks the element is there or not in the it variable. If it is there, and it will come inside and get that value with the next method. So see that iterator interface, it equal to collection name dot iterator method. Widely used syntax, this one. If you use this and immediately you call while loop, while, so this variable dot has next, you're just checking. Okay, element is there. Okay, go inside and fetch that value with the next method. Next method, it will fetch what value is there in this variable, and cursor will move automatically to the next element in this collection. And that will fetch by this and stores here and keep iterating this from first element to last element. So that is this iterator interface. So any questions on collection methods, iterator methods are very crucial. Okay. So no questions. Let's move on to the list interface. So list is a sub interface of a collection interface. Collection is the parent for list interfaces. So it contains based on the index based methods. So you want to fetch element from the collection based on index, you can use a list. You want to insert element in a particular position, you can use add method. So you can delete the element based on particular position, you can use remove method. So index based methods, this list will provide for us. So list, see this is a public interface. List extends collection. And add, see that int index. We have seen previous collection method is add element. But this add method is, say, two parameters. One is index, one is element. But this is coming from the collection interface. But this one is declared in the list interface. Declared, not implemented. Just interface means it's a declaration only, right? Abstract methods. Same way, add all collection C. There is a one more method, add all int index collection C. So you can add this group of elements in this position. That's our index based methods. So you have equals method, clear method, hash code. The most widely used method is a get method. Okay, you want to fetch the element from the collection. How can you fetch? So just call collection name dot get and give the index. number. Then you will get the value of that position. And then we have a is empty. You can check so whether the collection is empty or not. Last index of, so you can fetch the last index of this object. So you know to array, it converts the collection into array format. Contains we have seen. Here you have a contains all. You want to check these collection of elements are present here. Then you can check contains all. There is a contains single object, contains multiple elements. Index of object. So remove int index. Remove object. So remove all. Remove all removes the collection. So it is used to remove all the elements from the show collection. So that's a remove all, retain all different elements. And another mostly used one, set. Set is, or you want to set in this position this element, then you can use a set method. So when you're working with the programs, all these methods are very, very useful. Even you can sort the elements, comparator based elements, you can sort. It is used to sort the elements of the list on the basis of specified comparator. So these are the methods of a list interface. So index based methods are very, very special in the collections. There's multiple interfaces, right? They declared the methods and implemented in the classes. That's what we are coming here. There is a list iterator also, one more. So we have seen iterator, right? And there is a one more list iterator. So list iterator, you can traverse the elements in backward and forward direction, only list elements. So list iterator extends iterator interface. So the parent of this one is iterator. Just now we discussed iterator has next to next methods. Now this interface has, you can go back, you can get the previous element, you can get the next element, so you can check next element is there or not. So this iterator has next to. Now extra you got has previous methods. So that's the extra methods you got in this list iterator. So that's it. That we don't want to focus much on this, but this is the one very important. So ArrayList. ArrayList is, as I mentioned, it is used to store elements dynamically. You can store the elements dynamically using ArrayList. So it inherits the abstract list class and implements the list interface. So that is this ArrayList means. ArrayList contains duplicate elements. Even list contains duplicate elements. You can add duplicate elements. Also, list maintains the insertion order. Which order you inserted, that order will return to you. And also list contains duplicate elements. List contains duplicate elements. And a list is a non-synchronized. So ArrayList is a non-synchronized. And ArrayList allows you to access randomly because array works based on the index, right? That's why you can access randomly wherever you want elements. And ArrayList manipulation is slow because a lot of shifting needs to occur. If any element is removed from the ArrayList, it has to move here and there. So that's the ArrayList main concept. So ArrayList extends abstract list, and implements a list interface. This is the complete structure. See, a public class arrayList, extends abstract list, implements list, random access, clonable, serializable. So these are all interfaces. See, multiple interfaces you are implementing in this arrayList class. How this is abstract list also you are implementing here, right? In the arrayList, many are implemented here. See, ArrayList constructors, you can see without any parameters, with parameters, and with integer capacity. These are the constructor overloading also we call this. Same methods will be there. Again, you don't need to discuss the methods once again. But first these points you need to understand. So ArrayList is a class which is used to store a dynamic array of elements. So ArrayList class uses a dynamic array to store the elements. So it inherits the abstract list class and implements list interface. Okay. So that is all about ArrayList class. But I don't want to explain all these methods because we already discussed. Okay. So this is a very important interview question. So why do you use array when there is when ArrayList is available? Or vice versa, right? Whatever it is. So if there is a array, why do you need ArrayList again? So these are the so two important interview questions. This is the very important interview question. Okay, so you have array. Again, why do you need ArrayList? Array is solving, right? Array also you can store multiple elements.
It is a fixed size, right, Ramesh? Array is a fixed
That
size.
part. So we'll discuss all these points. So both purposes are different. So you can see the choice between using array or ArrayList. It all depends on specific requirements, how you are using them in your programming. So both arrays and ArrayList have their own advantages and disadvantages. So based on the type of application you are using, that depends on that. You have to choose in between these two. So let's understand first when you can use arrays. So arrays have a fixed size. So once you declare the array, it's a fixed in size. You cannot change it at runtime. So if you know the size of the data, you need to store and it won't change. So arrays are more memory efficient and slightly faster than dynamic data structures like ArrayList. So because the arrays don't need to dynamically allocate memory, that's why they're a little bit faster than ArrayList. So one is fixed size and memory efficient because they already allocated in the memory and directly can access quickly. That's why memory efficient, slightly faster than this ArrayList. Performance critical applications. So suppose where every CPU cycle and more allocation matters for you. So CPU usage and the memory allocation matters. Arrays can offer better performance because they have less overhead, right? Compared to dynamic data structures like ArrayList. So that's why most performance you want to add, better go for the arrays, not for ArrayList. So under primitive types, another important thing is, so arrays are ideal for storing primitive data type like integer, double, so char. So this type of data, if you want to store, primitive data types are important. So you can use primitive data types because they don't require boxing and unboxing. So which can occur when storing this type of in an array list. Array list, if you are using objects, you have to box and unbox. So that you don't need here. So only primitive data you can store in the arrays. Objects also you can store, but mostly primitive data will be stored here. So use array list when dynamic sizing if you need. When you want a fixed sizing, go for arrays. When you want a dynamic sizing, go for array list. You don't know the size of your collection, go for array list. You know the size, go for array. You want more critical performance wise, go for arrays. Or you want to store primitive data, go for arrays. So that's the array usage. And when it comes to array size, array list, a dynamic data you want to store, dynamic size you want. So you don't know how many elements. So the size of your data you don't know, then you can go for the array list. So array list provides a more user-friendly and so APIs and methods compared to arrays. Arrays doesn't provide any methods, right? So to access the data, to do something, right? You have to depend on all the iterations or something like that. But you don't have methods. So, but array list has a built-in methods like adding, removing, manipulating elements. So more readable and maintainable you can do with these APIs. So even you can have a generics in the array list. You can store generic types, particular type of elements only you want in the collection. You can specify that with this generics concept. Suppose I want only string type. I don't want other type of objects. You can mention that the generic type and you can have only string type. Or you want only integer data, integer objects you can store with the integer wrapper class. So that is another generics you can use with the array list, but you cannot use with arrays. So collection framework integration. So if you're working with the Java collections, so you can integrate the collection framework. That means all the classes, like list to, set to, map to. So they can convert into array list and you can use them. So without any issues. So interoperability, basically array list can be easily converted to arrays using the toArray method, providing compatibility when working with APIs that require more arrays. So that's the main advantage and disadvantage. Based on that you can take a decision which one you want. Okay. Yeah, and array list is done now. Let's go to let's join back and we'll discuss our linked list. Okay.